chemistry class. In last video we have discussed the Werner's theory and valence bond theory. In this video we will discuss the examples according to valence bond theory. Okay, I have already teach you that what were the key points to explain the examples by BBT. First of all, we have to write the electronic configuration of central metal atom. Then lose the outermost electrons according to the oxidation state and show the spin of the electrons. And according to ligand nature, pairing or unpairing occurs of unpaired electrons of d orbitals. Okay, see, we have discussed the example of NiCl4. In this example, Ar 3d8 4s2 is the electronic configuration of nickel. The oxidation state of nickel in this coordination compound is +2. So 4s electrons are removed. Now we have shown the electrons of the 3d orbitals. Now Cl is weak field ligand, so pairing not occur. Okay, now we want 4 vacant orbitals to make coordinate bond with ligand. So 4 vacant orbitals here are 4s and 3 p's. Okay, now sp3 dihybridization will take place and the geometry of the complex will be tetrahedral. Okay, there is 2 unpaired electrons, so compound will be colored and paramagnetic also in nature. Okay, this all we have discussed in last video. We will discuss now next example of this type. The example is NiCN4-2 means tetracyanonucleate second ion. Here the oxidation state of Ni is +2 and the electronic configuration of Ni is same 3d8 to 4s2. In 4s2, 4s2 are removed in oxidation number +2 means Ar3d8. 8 electrons are 1, 2, 3, 4, 5, 6, 7 and 8. It is the spin of the electrons. Now Cn- is strong field ligand. Strong field ligand means it will pair the electrons. So pairing will occur and the electronic configuration becomes like this. Now 4 vacant orbitals are required to make 4 coordination bonds. So they are 1d, 1s and 2p orbitals take part in hybridization and dsp2 hybridization will occur. Okay, now in next 4 3d electrons are fully filled and the dsp2 hybrid orbitals are coordinately bonded with Cn- ligand. Okay, in dsp2 hybridization the geometry will be square planar, means square planar is the geometry of this compound. There is no any unpaired electron, so the magnetic properties of this compound will be diamagnetic and it also colorless because there is no any unpaired electron, or we can say due to absence of unpaired electron. Thus we can explain the NiCN4-2 is square planar while NiCl4- was the tetrahedral in geometry. Same examples, just same for PtCl4-2 and PtCN4-2. PtCl4-2 will be tetrahedral because there will be sp3 hybridization, and PtCN4- will be square planar because there will be dsp2 hybridization. Okay, NiH2O4+2 shows tetrahedral geometry. Why? Same, because H2O is weak field ligand, so sp3 hybridization will take place and geometry will be tetrahedral. PtCl4- is paramagnetic. Why? PtCN4- is diamagnetic in nature. Why? Same for NiCl4 and NiCN4. There will be the dsp2 hybridization PtCl4 like NiCl4. sp3 hybridization, unpaired electrons will be present, so the nature will be paramagnetic. While in PtCN4 there will be no any unpaired electrons, so the compound will be diamagnetic. PtH2O4+2 is colored while PtNH3O4+2 is colorless. Why? Same reason. There will be unpaired electron due to sp3 hybridization. There will be no unpaired electron because of dsp2 hybridization. This is strong field ligand and it is weak field ligand. NiCl4 is tetrahedral while NiCN4- is square planar. Why? Same reason. Weak field ligand, sp3 hybridization, strong field ligand, dsp2 hybridization. According to hybridization, geometry is despicted. Okay, example with only carbonyl ligand. We know that the oxidation number of CMA, central metal atom, will be 0 if only carbonyl ligands are present in entity. Okay, so we have taken example nickel tetracarbonyl, means tetracarbonyl 0. In the presence of carbonyl ligand, the oxidation state of nickel is 0. Oxidation of electronic configuration of nickel is Ar3D8 4s2. Okay, now we will show the electronic configuration of the d orbitals 1, 2, 3, 4, 5, 6, 7 and 8, and 2 electrons are present in 4s. But we know that carbon monoxide or carbonyl ligand is strong field ligand, so the electron will be paired to 3d. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The all 10 electrons are filled in 3d orbitals. Now we want 4 vacant orbitals to make 4 coordinate bond with carbonyl ligand. So there is 1s and 3p orbitals are available for the hybridization. So sp3 hybridization occurs. Okay, so the electronic configuration will be 10 electrons are filled in 3d orbitals, and all 4 carbonyl ligands will coordinately bonded in sp3 hybridized orbital. These are all carbonyl ligands. Okay, thus we can explain each and every property of the compound. Due to sp3 hybridization, the geometry will be tetrahedral. There is no any unpaired electron in this compound, so the compound will be diamagnetic and colorless also. This is the tetrahedral geometry. Okay, and diamagnetic colorless due to presence of all the electrons are paired. Okay, clear? Okay, now we will discuss the compounds with oxidation number 6. Okay, first of all, compare the geometry and magnetic properties of FeH2O6 and FeCN6-4. Okay, first of all, we have to calculate the oxidation number of Fe in both the compounds. In FeH2O6 plus 2, H2 is neutral ligand, so the oxidation number will be plus 2 as it is. While in FeCN6-4, the oxidation number is calculated as plus 2, means the both compound has same Fe plus 2 ion. Okay, now we will write the electronic configuration. Fe atomic number 26 means Ar3D6-4s2. When Fe plus 2 oxidation state is obtained, means 2 electrons are removed from 4s, means the electronic configuration will be 3d6 only. So in 3d6 means 1, 2, 3, 4, 5 and 6 electrons are present in 3d and all the orbitals are vacant. Now in FeH2O whole 6, the ligand is H2, that is weak field ligand, and here Cn minus ligand is present, this is strong field ligand. So now the pairing will be take place or not, it depend on the ligand. If weak field ligand is taken, there will be no any pairing of the electrons because it is weak field, while in the presence of Cn minus ligand or strong field ligand, pairing occurs. So H2O H2 is weak field ligand, so the 4s, 4p and 2 4d electrons will take part in hybridization to make 6 hybrid orbitals with same energies, means sp3d2 hybridization will take place, while Cn minus is SFL and means strong field ligand, so pairing takes place, electrons are paired in 1 and 2. Okay, now the electron configuration will be 1, 2, 3, 4, 5, 6. Now this 2d electrons, 1s and 3p electrons will take part in hybridization, means sp3d2 hybridization will take place. Now you can explain each and every property of the compound. 6 ligands are present, means octahedral geometry is obtained for both. Okay, but there is 4 unpaired electron in the presence of H2O. So this compound FeH2O6 plus 2 will be paramagnetic and colored also. While FeCN6 minus 4, there is no any unpaired electron, so the compound will be diamagnetic and colorless also. Here the hybridization is sp in FeH2 whole 6. The hybridization is sp3d2, means outer d orbitals take part in hybridization, means it is high spin or outer orbital complex, while in FeCN6 minus 4, due to presence of Cn minus, inner d orbitals take part in the hybridization, so this is inner orbital or low spin complex compound. Okay, see, this is FeH2 whole 6 plus 2 and this is FeCN6 whole 6 minus 4. High spin orbital complex, this is inner orbital complex. This is paramagnetic and colored because of unpaired electrons. This is diamagnetic and colorless because of all the electrons are paired. Okay, clear? Oh, now, next example is Zn(F6 minus 4), means hexafluorozincate second. Oxidation number is second. Zn means 30 atomic number. The electronic configuration will be 3d8 4s2. In Zn plus 2 electronic configuration, it will be 3d8. 2 electrons are removed from the 4. Now here 3d orbital is fully filled. So there is no effect of weak field ligand or strong field ligand because of fully filled 3d orbital. So F minus is weak field or strong field. There is no any change in the electronic configuration. So for the 6 coordinate bonds, their 6 vacant orbitals are from 4s to 4d. So the hybridization will be sp3d2. Okay, next, see, this is sp3d2 configuration and all the electrons are paired here. In sp3d2 hybridization, 6f minus ligand make 6 coordinate bonds to make octahedral geometry, and there is no any unpaired electron, or we can say all the electrons are paired, so the diamagnetic and colorless also. All the coordinate compounds of Zn plus 2 ions are colorless. There is no any color in the compound because the ligand is strong field or weak field. There is no effect of the orbital because all the in 3d orbitals are fully filled. So same for Zn(NH3 whole 6 plus 2. It is strong field ligand, but Zn is in plus 2 oxidation state, or ZnCN6 minus 4. Here is also it is strong field ligand, but Zn plus 2, all the 3d orbitals are paired. So all the examples of the Zn plus 2 ions are octahedral, high spin or outer orbital complexes, diamagnetic in nature and colorless. Okay. Now we will compare the chromium complexes with weak field and strong field ligands. Just same as in Zn plus 2, there will be no any effect of strong field or weak field ligand in the chromium plus 3 complexes. See why? This is hexachloroidochromate third ion and this is hexaamine chromium third ion. Means the oxidation of Cr is plus 3 in both the complexes. So the electronic configuration is 3d5 4s 1 in both the complexes. When plus 3 oxidation state takes place, means 3 electrons are removed, means 3 from 1 from 4s and 2 from 3d. The remaining electronic configuration will be 3d3. Here is also 3d3. 3d electrons means D3 means 3 electrons are present in Cr plus 3. For 6 coordinate bonds, we have 6 vacant orbitals. There is already 2 d orbitals are vacant, 1 s and 3 p orbitals are vacant. There is no need to pair up the unpaired electrons by the power of ligand. So there is no effect of the ligand nature. So here is also the hybridization will be D2sp3. Here also the hybridization will be D2sp3. Okay, so both the compounds are octahedral, both the compounds of inner orbital complex, both are low spin complex, both have unpaired electrons, so both are paramagnetic and colored also. Clear? There is no any effect on Cr plus 3 and Zn plus 2 orbit complexes on the nature of ligand. Okay. Now we will discuss the last example of cobalt third ions. we will compare with weak field and strong field ligand. Compare COF6 minus 3 and CONS3 plus 3. In both the compounds, the oxidation state is plus 3. Okay, it is also in plus 3 oxidation state, is also in plus 3 oxidation state. It is in the influence of weak field ligand, it is in the influence of strong field ligand. Okay, now 27 is the atomic number of cobalt. The electronic configuration will be Ar3d74s2. Okay, when plus 3 oxidation state is obtained, means 3 electrons are removed, 2 electrons from 4s and 1 electron from 3d, means it will be 3d6. So the electronic configuration will be 1 2 3 4 5 and 6. Now the weak field ligand and strong field ligand influence the electronic configuration of the compound. In a weak field ligand, there is no pairing take place in the compound, so the hybridization will take place between the sp3d2 sp3d2 when F minus ligand is taking part in the complex. Okay, so sp3d2 hybridization will take place, while when ns3 means high strong field ligand will take place in the complex formation, the two electrons are paired up. In the presence of weak field ligands F minus, the pairing does not take place and sp3d2 hybridization take place. Okay, while in ns3 it is strong field ligand, so pairing takes place and d2sp3 hybridization occurs. Okay, clear. Now there is 4 unpaired electrons while there is no any unpaired electron, so the magnetic properties and colored nature is changed for both compounds. So let's see CO plus 3 in the influence of F minus ligand, octahedral, 4 unpaired electrons are present, so it is colored and paramagnetic in nature. Outer d orbitals takes place in the hybridization, so it is high spin or outer orbital complex. While in CO ns3 whole 6 minus 3, in the influence of ns3 all the electrons are paired, the octahedral geometry is obtained, but there is no any unpaired electron, so it will be diamagnetic and colorless. And inner d orbitals taking part in the hybridization, so it is low spin or inner orbital complex. Clear? Thus we can explain the geometry and paramagnetic properties and colored properties of the any compound in the presence of weak field or strong field ligands. Thank you.